In chapter number 12 of this course, we're going to discuss SQL Plan Management. After you have completed this lesson, you should be able to manage SQL performance through changes, set up SQL Plan Management, set up various SQL Plan Management scenarios, and use a technique to load hinted plans into SQL Plan Management. Now, the first topic that we're discussing in this chapter is, what is this maintenance of SQL performance? Now, maintaining SQL performance requires the utilization of SQL Plan baselines. And it actually comes down to the following. Let's say that you have an application that is launching SQL statements within your database. The optimizer renders execution plans for those SQL statements, and the execution plans being rendered are showing a very good performance. However, sometimes certain changes are happening within your database, like collecting new optimizer statistics or a parameter is being changed. Those changes can have an influence on the execution plans that are being rendered by the optimizer. So it can be that if you launch an SQL statement, it's executed with execution plan number 1, and we're really happy with that plan. Then a change is being made to the database. And then for that same SQL statement, suddenly it's generating another execution plan. Now, what we will try to avoid is that if the new execution plan would show a regression in performance compared to the initial execution plan being used, that we temporarily do not use that newly generated execution plan, but that we still use the initial execution plan. So maintaining SQL performance is avoiding regression of execution plans of SQL statements. Now, the maintenance of SQL performance is handled by means of SQL Plan Management. So SQL Plan Management is a preventative mechanism that records and evaluates the execution plans of SQL statements over time. So what you will have is, you have an SQL statement. An execution plan is being generated for the execution of that SQL statement, and we are happy with that plan. It shows a very good performance. If then a change is being made, maybe another execution plan is now being generated for that same SQL statement. What we do not know up front is, does this new execution plan have the same or a better performance than the initial execution plan that was used? Well, with SQL Plan Management, we temporarily are not going to use the newly generated execution plan, but we'll still be using the initial plan. The optimizer will automatically manage those execution plans and will only use known and verified plans. Now, the new execution plan that was generated after a change has been implemented into the database can then over time be verified with the initial execution plan. And if that new execution plan shows the same performance or gives even a better performance than the initial plan, from that point in time on, that new execution plan can be used. If after comparison, the new execution plan with the initial execution plan, the new execution plan gives a worse performance than the initial plan, that execution plan cannot be used. And this is the primary goal of SQL Plan Management. It is to prevent performance regressions caused by plan changes. Now, what are the components of SQL Plan Management? There are actually 3 major phases. You have on one hand the plan capturing. And the SQL plan capturing is a technique for capturing and storing relevant information about the plans in the SQL management base for a set of SQL statements. Because, of course, if you want to compare execution plans, you must have a mechanism to capture those execution plans. Now, once execution plans have been captured, the optimizer, that always is building up an execution plan, is then going to check if that execution plan that it just has generated, if it can be used. If it cannot be used, the initial execution plan will be chosen, in fact. That's the plan selection. And then you have the other phase is called the plan evolution, that if new execution plans are being rendered, they are being captured, but then over time they will be evaluated against the initial execution plans to see if they give a better or a worse performance than the initial plans. So these are the three major components of SQL Plan Management. We're going to discuss those three major components throughout this chapter. Now, first of all, SQL Plan Management makes use of so-called SQL Plan baselines. So what's going to happen is that execution plans are going to be captured. Now, in order to be able to capture those execution plans, we have to need. Now, what is the SQL Plan baseline architecture? The SQL Plan Management feature introduces the necessary infrastructure and services in support of plan maintenance and performance verification of newly generated execution plans. The SQL Plan Management functionality will capture execution plans. This means that those execution plans need to be stored somewhere. Well, the storage of the captured execution plans is done by using the SysOx table space. So it's in the SysOx table space. What is the architecture behind this SQL Plan Management? SQL Plan Management captures execution plans generated by the optimizer. That means that those execution plans need to be stored somewhere. Well, space of the SysOx table space will be used to store the captured execution plans. Now, the amount of space that is allocated from the SysOx table space to store those captured execution plans is called the SQL management base. Now, when the mechanism is active, if then a statement is executed minimum 2 times, the generated execution plans of that SQL statement will be captured and placed in the SQL management base. More particularly, it will create for your SQL statement for which it captured execution plans, it's going to set up a plan history, in fact. So every SQL statement that is executed minimum 2 times will have its own plan history. And the collection of plan histories per SQL statement, that is called the statement log, which is placed inside the SQL management base, which is consuming space of the SysOx table space. Now, what you need to know is that the very first plan that is captured for an SQL statement is considered a plan baseline. That means that that execution plan can be used by the optimizer if the optimizer generates that particular execution plan. So the first execution plan is captured and is set immediately as a plan baseline. What you will have is, if then that statement is being launched again and the optimizer would come up with another execution plan, it's going to check if that new execution plan is already in the plan history of that statement. If it's in there, it's going to be a plan baseline, he can use it. If the statement is not in the plan history, the execution plan will be placed in the plan history, but it will still use another execution plan that is considered as a plan baseline. If then that statement is being executed again and it generates again this execution plan, what you will have is he will see that's in the plan history, but he doesn't see it as a plan baseline, so he cannot use that execution plan and he will still use a plan baseline. Yeah, plan baseline is an execution plan that is considered to be a good execution plan. Execution plans that are placed inside the history can then be evaluated against plan baselines, and if those execution plans give a better or the same performance as a plan baseline execution plan, it will become a baseline plan and can be used in case the optimizer would render that execution plan. Now, what are the basic tasks in this SQL Plan Management? Well, they are listed on this slide. So first of all, you have to configure SQL Plan Management. I will show you how you can display plans in an SQL Plan baseline. We're going to discuss that you can also upload execution plans yourself manually. You can then also evolve SQL Plan baselines. So compare the performance of different execution plans manually, or you can have it done automatically. You can also drop SQL Plan baseline, and you can even manage the SQL management base. Like for instance, you can state what is the maximum amount of space that can be used of the sysocs table space to support this SQL Plan Management feature. Now, first of all, you have to configure SQL Plan Management. Now, there are parameters, there are packages to be used in order to configure SQL Plan Management. But what I will do first is I will show you an example of SQL Plan Management, how this mechanism works. So let me show you my demo environment, and look. First of all, by default, the mechanism of SQL Plan Management is not active because by default execution plans are not being captured. And that's what I've done before I've activated the SQL Plan Management. Is simply I logged in as HR, and you see that at that moment in time the optimizer mode is set to all rows. And then I executed a select statement. By the way, this is not a hint, it's simply a comment, so I can afterwards easily find back my statement. But I execute that statement, and what do I see is that the optimizer comes up with a full table scan. So if I execute this statement with optimizer mode equal to all rows, the optimizer comes up with a full table scan execution plan. Now, what did I do then is I've changed my optimizer mode to first rows, and then I executed that same statement again. And because of the fact that the optimizer mode is set to first rows, the optimizer will take that into consideration and says, I think the best way to carry out that select statement, if optimizer mode is first rows, is by doing a bitmap index scan. So SQL Plan Management at this moment in time is not active. If my optimizer mode is all rows and I execute that statement, optimizer comes up with a full table scan. If I put the optimizer mode to first rows, the optimizer for that same statement says you're better off with a bitmap index scan. This is how my demo behaves before SQL Plan Management is active. Now, then what I did is the following. Now I'm going to activate the mechanism and show you the effect of that mechanism. So I logged into my database, and then you have two parameters that play a role in this SQL Plan Management. You have optimizer capture SQL Plan baselines and optimizer use SQL Plan baselines, which is set to true. So you can say use SQL Plan baselines is true. It means that SQL Plan Management is active. Yeah, it is active, but the entire mechanism of SQL Plan Management depends on execution plans being captured, in fact. And you see that the capturing of execution plan is false. So if there are no execution plans being captured, it means that the SQL Plan Management mechanism is not in effect either. Now, look, what did I do is, however, at this moment in time, I've said, look, from now on, capture the execution plans of statements that are being executed minimum 2 times. And for those statements, per statement, it will create an SQL plan history in the SQL Plan Management base. Now you see that my optimizer mode is all rows. Now, this is the very first time I'm running that query. It's a script that I'm launching, but I'm running that query that I've shown you before. Now we know I've just activated the SQL Plan Management feature. The optimizer mode is all rows. We know for that statement that the optimizer comes up with a full table scan. Now what will happen is the optimizer comes up with an execution plan. It's going to be a full table scan, but this is going to be the very first plan that will be placed in the plan history for that statement, in fact. Now, the very first execution plan captured for an SQL statement is considered as a plan baseline. And that's what you're seeing here, is that the execution plan is a full table scan, as expected of all rows, but this is the very first plan that was captured after activating SQL Plan Management. And you see that SQL Plan Baseline is used for this statement. So that execution plan that I see here is an execution plan that is considered as a baseline plan. The very first plan that is being captured is by default a baseline plan. It's a plan that can be used by the optimizer if he comes up with that execution plan. But then what did I do is, you see here, for instance, I have a script file show plan baseline.sql. So there is a view where you can look up information about SQL plan baselines. And I'm looking up if there are any baseline or execution plans captured for a statement that starts with select load auto. That's that command that I'm using to quickly find my statement back. And what do I see is that for that statement over here, an execution plan has been captured automatically, in fact. And what do I see is that it is an accepted plan. This means if the optimizer comes up with that particular SQL execution plan, he will see it in the history. He sees that it's accepted, so it can be used, in fact. Now, the thing is the following. Now I'm putting my optimizer mode to first row. So I'm making a change in my database and I'm running my query again by launching that script file, in fact. Now, if it was first rows, I've shown you before I activated SQL Plan Management, I've shown you that the optimizer comes up with a bitmap index scan. Yeah, but now that it's active, what do I see is that the execution plan being used is the full table scan. Now, believe me, he did generate a bitmap index scan execution plan. But then the optimizer says, am I allowed to use it? So he's going to check, is that plan already in the history of that statement? Now, it's not at that moment in time, so he will put it in the history, but he says, I do not know if this gives a better performance than the execution plan that was used before, and that is the full table scan. So he puts the bitmap index scan execution plan in the plan history, and he says, I'm still using the full table scan because I do not know if the bitmap index scan gives indeed a better performance than the full table scan if my optimizer mode equals first rows. And you will see that an SQL plan baseline has been used for this statement. Now, if now I'm going to request, can you show me the execution plans that have been captured for that particular select statement, you will see suddenly that I have two execution plans for that statement that have been captured and placed in the history, but only this plan is an accepted plan. It's a plan that can be used if it is generated by the optimizer. While this plan, and I will show you that later on, this is that bitmap index scan. If the optimizer comes up with that execution plan, at that moment in time, it cannot use that execution plan. Now, what you can do is, I have here a script show xplan baseline.sql. You can actually show the execution plans of SQL Plan Baselines. It's a function of that package, dbms xplan, and I'm asking, can you show me all of the execution plans that have been captured with this particular SQL handle, which is the same SQL statement. And what do I see is that I have here an execution plan full table scan, which is an accepted plan. That is, if it's generated by the optimizer for that particular select statement, it can be used because it's in the history and it's an accepted plan. Once again, the very first plan that is ever being captured is always considered as an accepted plan. But there is also another execution plan, and that's the one with that bitmap index scan, but it says not accepted. So if this execution plan is being generated for that select statement, the optimizer says it's in the history, but it's not an accepted plan, so it's not a baseline plan. Yeah, but then I cannot use that plan, and I will have to choose the plan that is considered as an accepted plan as a baseline plan. You control SQL Plan Management with initialization parameters like optimizer capture SQL Plan baselines, which you must set to true if you want to perform automatic capturing of execution plans. And to activate the mechanism of SQL Plan baselines, make sure the parameter optimizer user SQL Plan baselines is set to true. You can also configure the automatic SQL Plan Management Evolve Advisor task using the set evolve task parameter procedure. You can also set the accept plans to true, which is the default, so that SQL Plan Management automatically accepts all plans recommended by the SQL Plan Management Evolve Advisor task. Now there are two ways of capturing execution plans or placing execution plans in the plan history of an SQL statement. You have on one hand the technique of automatically capturing execution plans that are generated by the optimizer. And that's by means of setting the parameter optimizer capture SQL plan baselines to true. So every execution plan that is being rendered for a particular SQL statement will be captured and placed in the SQL plan management base. Now, once again, the very first execution plan captured for an SQL statement is placed in the plan history and is automatically considered as a plan baseline, meaning an execution plan that can be used if it was rendered by the optimizer. If then another execution plan would be generated for that same SQL statement, it will automatically capture this, but that newly generated execution plan that is being captured is placed inside the plan history, but the initial plan will still be used. It's only after evaluation of this newly captured execution plan against the initial plan that we can see, okay, does this new execution plan give the same performance or a better performance than the plan baseline? If so, that new plan also becomes a plan baseline, and it can then be used if it is generated by the optimizer. If not, it simply stays in the plan history, but it does not become a plan baseline. So this is one technique of capturing execution plans or placing execution plans in the SQL management base, is by putting the parameter optimizer capture SQL plan baselines to true. However, if you're going to execute, for instance, an SQL statement, the text of that statement as well as the execution plan will be stored, for instance, in the library cache of your database instance environment. Also, maybe you have created an SQL tuning set, which is an Oracle object that contains SQL text, execution plans of those SQLs, and optionally execution statistics. So it's an object that also contains execution plans. Now you have the possibility via the package dbms spm to upload execution plans found in the cursor cache or execution plans that are placed inside an SQL tuning set. Via that package, you can upload that into the SQL Plan Management base. Now, what is important to know is that if you upload manually execution plans of SQL statements, those SQL execution plans are automatically plan baselines. So they can immediately be used if they are rendered by the execution. How do you get execution plans in the SQL Plan Management base? Well, you have one technique of automatically capturing execution plans rendered for SQL statements. And that's by means of setting the parameter optimizer capture SQL plan baselines to true. That means if a statement is executed an execution plan is being rendered, the plan will be placed inside the SQL plan history of that statement. Now, the very first plan captured for an SQL statement is placed in the history, but it's also automatically a plan baseline, means a good execution plan. If then suddenly, for that same SQL statement, another execution plan is being generated, the plan will be placed in the history, but it will initially use the first plan being captured, in fact. Then you can perform an evaluation of this newly captured execution plan. You can do that yourself, or this can be done by the tuning advisor. And if that newly generated execution plan gives the same or a better performance than the plan baseline, the first plan being captured, it can become a plan baseline, meaning that it's an execution plan that can be used if it's being rendered by the optimizer. If that newly captured execution plan, after evaluation against the plan baseline, does not give the same or better performance, it will stay in the plan history, but it will not become a plan baseline, meaning that if that execution plan is rendered by the optimizer, it will not be used. It will still be using a baseline plan. So this is the automatic capturing of execution plans. But you also have the possibility to manually upload execution plans into the SQL Plan Management base. For instance, in your cursor cache, you will find SQL statements and their execution plans used for the execution of those SQL statements. Or you might have created an SQL tuning set, which is an Oracle object that contains SQL text plus execution plans. Well, you can upload execution plans from the cursor cache or execution plans of the SQL tuning set into your SQL Plan Management base. Now, very important to know is that execution plans that are manually uploaded via that package dbms spm, they are automatically plan baseline. That means if an execution plan is being rendered for that statement and it's the plan baseline, it can be immediately used. So once again, execution plans that are manually uploaded are automatically plan baselines, meaning execution plans that can be used if rendered by the optimizer. Now, how does this mechanism of SQL plan selection work? Well, first of all, a user is going to execute an SQL statement. As always, that doesn't change. As always, the optimizer will build up an execution plan. But then the optimizer says, am I allowed to use that execution plan? Well, to see if the optimizer is allowed to use that execution plan, you must have SQL Plan Management being active. So the parameter optimizer use SQL Plan baselines must be set to true, in fact. Now, if it's not set to true, the execution plan that the optimizer just has rendered is going to be used, in fact. But if the mechanism is active, the optimizer says, I've generated this execution plan. I'm going to check, is that execution plan of the history, or is it a plan of the history of that statement? If it's already in the history, it's going to check, is it a baseline plan? If it is, it can be used. It's a good plan, in fact. Now, if the execution plan generated by the optimizer is part of the history, but it's not, it will be placed inside the plan history, and it will choose a baseline plan, the one with the lowest best cost. And that's the execution plan that is going to be used, in fact. Now, if the optimizer comes up with an execution plan, he checks, is it part of the history of that statement? Yes. Is it a baseline plan? No. Well, then I'm not going to use that plan, but I will choose the baseline plan with the lowest best cost, in fact. And whenever you're going to display execution plans, as a note, it will indicate if an SQL plan baseline has been used or not. But that's how the selection of the SQL plan is happening. Now, execution plans that have been captured are placed inside a plan history, but not all the execution plans are automatically plan baselines. The only plans that are automatically baseline plans is the very first plan that is being captured, or if you're going to upload manually yourself execution plans. Now, what do you have is, you have the package dbms spm, which has a function evolve SQL plan baselines. And what you can do is, via that function of that package dbms spm, you can ask, look, I have here an SQL statement with this SQL handle. There are a couple of execution plans already captured in the plan history. Maybe some of them already a plan baseline. Well, via that function, you can ask, can you please verify if execution plans in the plan history of that statement that are not accepted plans, can you please compare them to plan baselines? And if execution plans that are compared against the plan baselines give the same or a better performance than the baseline plans, they can be accepted. If not, they will remain simply in the plan history, but they will not become a baseline plan. They will not be set to accepted, meaning that those execution plans cannot be used if rendered by that optimizer. Now, evolve SQL plan baselines does the evaluation of the execution plans. You can then print the report, in fact, where you then will see the recommendations of that evolve task that you're having. Now, this is manually asking to perform an evaluation. You can also launch the SQL Tuning Advisor by launching the SQL Tuning Advisor yourself, or by relying on the automatic run of the SQL Tuning Advisor, which can give you recommendations which plans should be set to accepted or not. Now, what is Adaptive SQL Plan Management? Now, Adaptive SQL Plan Management is a new Evolve Auto task that runs in the nightly maintenance window. It will rank all non-accepted plans and runs the evolve process for them. Newly found plans are ranked the highest to be evaluated. The database will also purge plans that have not been used for longer than the plan retention period, which is default 53 tasks. Now, this new nightly maintenance task, in fact, is called sysauto spm evolve task, and the information about the task you can find that back in DBA Advisor tasks. Via the procedure report auto evolve task of the package dbms spm, you can review the results of this automatic evolve auto task. Now, what you can also do is you also have the possibility to have this evolve auto task to run on a more regular basis and not by default once a day. And this is the so-called automatic plan evolution task. But you can change it from a nightly maintenance task to a job that is being launched on a more frequently basis. So managing the SPM Evolve Advisor task. So the evolve function is now an advisory, and it allows the DBAs to create a task, evolve plans in the task, and so on. For that, you use the package dbms spm, where you're going to say, I would like to create an evolve task to evaluate the execution plans captured for a particular SQL statement. You then execute the evolve task, and you can then ask a report on the recommendations of that evolve task. Plus, you can then, via the subprogram implement evolve task, you can then implement those recommendations, in fact. Now, this is the evolve advisor task is something that you can run manually, but know, as stated in the previous slide, that this is also now nightly maintenance job that is being launched. Now, there are some important SQL Plan baseline attributes. So you have the possibility to look up information about the SQL Plan Management base. For instance, you have the data dictionary view DBA SQL Plan baselines, where you can find out for which SQL text, which SQL execution plans have been captured, in fact. And you can see for an execution plan, if it says accepted yes, it means that that execution plan is a baseline plan. So this means that if the optimizer generates that particular execution plan, it can be used, in fact. While a plan that says accepted no, what you will have is if then the optimizer generates that particular execution plan for that particular SQL statement, in fact, it cannot use that execution plan because it's not accepted, in fact. And it will choose one of the execution plans with accepted set to yes. You will use the one with the lowest cost, in fact. Now, what you have is you can, via the function alter SQL plan baseline of the package dbms spm, you can yourself, you don't have to necessarily run the evolve advisor task, in fact, but you can change a plan from accepted to non-accepted. You can also enable or disable a plan. This gives you the possibility to state, look, although it's an accepted plan, if I put it to enabled no, this means that this is an execution plan that can never be used. So these are some important SQL plan baseline attributes. For what can you actually use this SQL plan management base? Well, SQL plan management, the goal is to avoid regression of execution plans. What are the possible scenarios where you can use SQL plan management? On this slide, you have two possible scenarios for SQL plan management. First scenario is the database upgrade. So let's say you have an Oracle database 11G, 12C, and 18C. You have an application that runs upon that database. Execution plans are being rendered for the SQLs launched by that application. And those execution plans are good execution plans. The application is running in an optimal way. But now you have to upgrade your database to 19C. Now, what we do not know is that if you're going to upgrade to 19C, how would this affect the execution plans that will be rendered for that same application that will be working upon a 19C database? We do not know if the same execution plans are going to be generated. And if there are different execution plans being generated, do those new execution plans show a much better performance than the execution plans that were rendered in the previous version of the database? Well, what you can do is the following. You have your database 11G, 12C, and 18C. Your application is working upon it. It generates execution plans. We are happy with those execution plans. Well, we can then create an SQL tuning set that holds the SQLs launched by your application and their execution plans being used in your 11G, 12C, or 18C database. Then what you do is you're going to upgrade your database to 19C, but before the application starts working upon the 19C database, you're going to load the execution plans and the according SQL text from that SQL tuning set into the SQL Plan Management base. And I've told you already in the previous slides, I've told you that if you manually upload an execution plan, those execution plans, they are placed in the history, but they are immediately so-called baseline plans. So if now your application is now running upon 19C, an SQL statement is being launched, the optimizer renders an execution plan. If that execution plan is the same execution plan as it was rendered in the 11G, 12C, or 18C database, he will see it's in the history, he will see it's a plan baseline, and he will use it. However, if for that same SQL statement that is now being launched upon your 19C database, it comes up with an entirely new execution plan, he will see it's not in the history, so it will be placed in the history, and he will use one of the plan baselines for that statement, which are the execution plans generated in the previous version of that database. So we are initially still using the plans that we got in the previous version of our database. And then maybe whenever you run the Evolve Advisor or you have that nightly run, maybe the newly generated execution plan shows a much better performance for that statement than the old execution plans. Well, at that moment in time, that newly generated execution plan will become a baseline plan. So this is one scenario for which you can use SQL Plan Management. Another scenario is a new application deployment. What does this mean? Let's say you have a development database. Developers have built an application for you. They have tested it upon a development database. And what do you get is all good execution plans, in fact. Now, what you can then do is, if of course now your application is going to work upon your production database, there is a big chance that your production database is not configured in exactly the same way as that development database, in fact. Well, what you can do is let the application be running upon the development database. It comes up with well-tuned plans. You're happy with those execution plans. And then those execution plans can then manually be uploaded into the SQL management base of your production database. And once again, plans that you upload manually automatically are accepted plans. These are execution plans that can be used. If now that application runs upon your production database and it produces an execution plan for a particular SQL statement, if it's the same execution plan as it was rendered in the development database, it's in the history, it is a plan baseline, so it can be used. But if for that same SQL statement, the production database comes up with another execution plan, he will put it in the history, but he will initially use the execution plan that was rendered in the development database. And after an evaluation by you or by the automatic SQL Plan Management Evolve Advisor, the newly generated execution plan, if it shows a better performance than the plan baselines, the execution plans that come out of the development database, they will become accepted plans and they can be used. If their performance shows regression, they will never become a plan baseline. So this is a second possible SQL Plan Manageability scenario. Another scenario is the SQL Performance Analyzer and SQL Plan Baseline scenario. Now, first of all, in short, the SQL Performance Analyzer is a tool where you can evaluate the effect of a change on a collection of SQL statements. So what you're going to do is, with the SQL Performance Analyzer, you're going to run a specific SQL workload. Then you implement your change, and then you run that same SQL workload again, and then you're going to compare the before change run and the after change run. And the report of that SQL Performance Analyzer will tell you which statements show regression, show improvement, or shows no impact on the performance of their execution, in fact. That's actually what SQL Performance Analyzer is to see what the effect is of a change on a specific SQL workload. But how do you use this with SQL Plan Management? Well, let's say, for instance, the following. Once again, you have an 11G, 12C or 18C database. An SQL workload is launched upon it, and it gives you very good execution plans, in fact. Well, what you do is, those execution plans, you capture that into an SQL tuning set, and you're going to import that tuning set into your 19C database. Now, what you do is, you can then say, in my 19C database, I'm launching the SQL Performance Analyzer, and I'm going to run this SQL tuning set workloads in my 19C database, but with the parameter optimizer features enabled equal to 12. So the optimizer is still a 12C optimizer. Then I'm going to put the parameter optimizer features enabled to 19, and I'm going to run that tuning set again with the SQL Performance Analyzer. And then I'm going to check which statements of this SQL tuning set shows a regression in performance after the optimizer features enabled has been set to 19C. And for those statements that show regression in performance because optimizer features enabled is set to 19C, in fact, for those statements, I'm going to upload the plans that come out of the tuning set of my 11G, 12C or 18C database into their plan history. And what you upload manually are automatically accepted plans, in fact. So if then your optimizer feature enabled is 19, and for a particular statement he comes up with a bad 19C execution plan, he says, I'm going to put in the history, but I'm still using one of the plans that I've uploaded myself that were generated in an 11G, 12C or 18C database. So loading SQL plan baselines automatically is something that you can do by setting the parameter optimizer capture SQL plan baselines to true. Now, let's suppose a scenario. Let's say that you have a database 11G, 12C, 18C. You have an application that is running upon that database, gives you good execution plans, in fact. Now, the thing is, what you're going to do is you upgrade to 19C, but you keep your optimizer to behave as a 12C optimizer, in fact. Your application is running upon it. It's going to generate 12C execution plans for your statement, in fact. Now, the very first plan that is captured for your SQL is automatically a plan baseline, in fact. If then you put your optimizer feature enabled to 19, if then a new execution plan is being rendered for an SQL statement, I've already mentioned that, it's placed in the history and it will choose one of the accepted plans for that particular execution plan. If the new execution plan after evaluation shows a better performance, it will become a baseline plan, an execution plan that can be used for that particular statement, in fact. If not, it will never become a baseline plan, meaning that only new, better plans will be used. New plans that show regression will never become a baseline plan and that will be never used. Now, you can control via policies your SQL plan management base. You can control, for instance, how much space can be used of the sysaux table space for the capturing of execution plans. You can set it to 20%. The maximum is 50%, in fact. Also, execution plans that have not been used, let's say, in the past 105 weeks, will be automatically purged from the SQL plan management base. You also have the possibility, if you know the SQL handle, so that means the identifier of an SQL statement within the SQL plan management base, you can say for that particular SQL statement, please drop all the SQL plans that have been captured for that statement. Now, one last topic of this chapter is loading hinted plans into SQL plan management. It's actually another scenario for which you can use SQL plan management. So let's say, for instance, the following. Now, you have an application for which a plan is being rendered, but that plan doesn't seem to be the most optimal plan, in fact. The problem is that to have a much better plan, we have to have access to the source code of that application because we need to rewrite the SQL. Yeah, but that's not always possible to modify your source code, in fact. Well, what you can do is the following. Execute the original SQL with the original plan, of which you say, look, this is not the best execution plan, in fact. But what you can do is, you can actually, from your library cache, you can load the original plan yourself in the plan history of that statement, in fact. What you upload yourself is automatically an accepted plan, in fact. So it's a plan that can be used if generated by the optimizer. And then what you do is, you actually take the coding of that SQL statement, but you put in hints to force the optimizer to go for a specific execution plan for that statement, in fact. So you take the original SQL, but you're going to decorate it with hints to force the optimizer to come up with a certain execution plan, of which you say, look, this is a much better plan than the original plan. What you can then do is, this execution plan that was generated due to hints, in fact, you can then also upload them into the plan history of the original SQL via the package dbms spm, you can select that execution plan that should be associated with that SQL statement history in the SQL Plan Management base. Plus, what you then also have is you can then also destroy the original plan, of which you select, actually, this is not a really good execution plan, in fact. But this is now your baseline plan, in fact, for the original SQL. So if now the original SQL is being executed, he will always, even if he comes up with another execution plan, he will always use that hinted plan, because that's the one that you have uploaded yourself. And what you upload yourself is automatically set as an accepted plan. Now there is a small quiz on this chapter. So whenever the optimizer use SQL plan baseline parameter is set to true, the optimizer does not develop an execution plan. It uses an accepted plan. It compares the plan that it develops with accepted plans in the baseline, or it compares the plan that it develops with enable plans. Does not develop an execution plan. It uses enable plans in the baselines, or it develops plans and adds them to the baselines as verified. Now the right answer is B. SQL Plan Management does not say to the optimizer, now you have to use that execution plan. No, the optimizer, as always, will come up with an execution plan, but is then going to see with the help of the SQL Plan Management base if that execution plan can be used or not, in fact. So the right answer is B. It compares the plan that it has developed with the accepted plans in the baseline. So in this lesson, you have learned how to manage SQL performance through changes, how to set up SQL Plan Management, and we have seen various scenarios where this SQL Plan Management functionality can be useful. There are some exercises that you can make for this chapter, and those exercises will cover the use of SQL Plan Management. Practices for Lesson 12, SQL Plan Management. SQL Plan Management, SPM, is an Oracle database feature that provides controlled execution plan evolution. With SPM, the optimizer automatically manages execution plans and ensures that only known or verified plans are used. When a new plan is found for an SQL statement, it will not be used until it has been verified to have comparable or better performance than the current plan. SQL Plan Management has three main components: plan capture, plan selection, and plan verification. In these practices, you see each of these components in action. Now, in these exercises, you will see all the phases of using SQL Plan Management. Now, before you start the practice, make sure that you always change your directories to point to SPM, and also flush the shared pool to be sure that there is no interference from preceding practices. So here I changed my directory to SPM. Here I changed it to SPM, logged in as sysdba, switched to container orclpdb, and I've flushed my shared pool to have a fresh start for the observations of the exercises of this chapter. Then the first component that we're discussing is plan capture. There are two main ways to capture plans. You can do this automatically at runtime or via a bulk load. Now in this practice, you will enable automatic plan capture so that the SPM repository is automatically populated for any repeatable SQL statement. You can enable automatic plan capture by setting the optimizer capture SQL plan baselines parameter to true in your session. So what I'm going to do is I'm going to change my directory to SPM, log in as the SPM user. I'm going to execute the command show parameter baseline. Now what do I see is that the optimizer capture SQL plan baselines parameter is set to false. This means that there is no automatic capturing of execution plans. If you want to activate this, you have to set the parameter optimizer capture SQL plan baselines to true. So I'm going to copy paste this command to set that parameter to true. Plus, for the sake of the exercises, I'm now also going to put first the optimizer mode to all rows, which will influence the decision making of the optimizer. Then what you need to do is you will have to launch the following query minimum 2 times for the execution plan to be uploaded into the SQL Plan Management base. You can type in the command and execute it twice, or you can launch this script 2 times. So I'm going to copy paste this, I execute this, and I'm going to execute that statement again by launching that script file. Now an execution plan has been generated for that select statement, and with the second execution, that execution plan has been automatically captured and placed inside the SQL plan history for that particular statement. And the very first execution plan that has been captured is considered to be a baseline plan. Now you have the possibility to get the information concerning baselines and captured execution plans and to see whether they have been enabled or not. You can even tell if the plan was captured automatically by checking the values in the original column of the data dictionary view DBA SQL Plan Baselines. Now by running this script, you can obtain that information. And what do I see is that for this select statement, an execution plan has been captured. And you see in the origin that this is an execution plan that was automatically captured. And you also see that the column enabled says yes, and that accepted says yes. And accepted yes means this is a baseline plan. This is an execution plan that can be used if it was rendered by the optimizer for that particular select statement. Now what we're going to do is we're now going to change the optimizer mode to first rows. Believe me, this is going to lead to the generation of a different execution plan than when optimizer mode was set to all rows. That's a new execution plan. It will be captured, but it's the second one that is now being captured. That is not automatically being considered as a baseline plan. You will see that the accepted value will be set to no. So first I'm going to put my optimizer mode to first rows. Then I'm going to execute that same statement again, like this. Now, first rows will have generated a new execution plan and it will be captured for that statement. So I'm going to check the baseline. Now, what do I see now is that I have 2 execution plans that have been captured for the same statement. The first one that was captured is always an accepted plan, in fact. The second one was also automatically captured, but the second one is not by default being set as an accepted plan. That's why you see here accepted no. So you see 2 plan baselines for your query, but the new plan has not been accepted. This new plan will have to be validated before it's acceptable as a good plan to use. Now we're going to reset the optimizer mode and disable the automatic capturing of SQL Plan Baseline. So I'm putting optimizer mode back to all rows. And I'm going to put the parameter optimizer capture SQL Plan Baselines. I'm going to put it back to false, like this. Then also, we're going to purge the plan baselines and confirm that the SQL Plan Baseline for that statement is empty. So I'm going to call upon this script file, to delete SQL Plan baselines. And you see now via my view DB SQL Plan baseline that I no longer have captured execution plans for that particular select statement. I've also disabled the automatic capturing of execution plans. Now you also have the possibility to load plans from SQL tuning sets. To show you this is going to first run this script file to perform the explain plan command for that select statement. We know that our optimizer mode is set to all rows. So if I'm going to execute that particular statement, so I'm going to copy paste this, run that script, it's going to be a full table scan. The plan is not being captured automatically because I have deactivated this. But what I'm going to do is I'm actually going to execute now that statement. So the statement text and its execution plan, which is a full table scan, will be placed inside the cursor cache of my shared pool. Then what we're going to do is we're going to put the optimizer mode to first rows. And we're going to do again the explain plan command for that same statement. So I'm running that same script file again. And what do I see is that for first rows, the optimizer says, I think we're better off with a bitmap index scan. And we're going to execute that statement so that that statement and the bitmap index scan execution plan is placed inside the cursor cache of the shared pool. I'm going to execute this and I do this. Now, so now I have twice the same statement in my shared pool. One has a full table scan, the other one is using a bitmap index scan as execution plan. And I'm going to put my optimizer mode back to all rows. Now we're going to check the baselines. So I'm going to run this script file to check if execution plans have been captured for that statement. And what do you see is no row selected because I've disabled the automatic capturing of execution plans. But now what we're going to do is we're going to create an SQL tuning set that captures the select statements that contain the load STS hint. In fact, those statements are in the cursor cache. So like I've said, I have twice the same statement inside my cursor cache, but there is one with a full table scan as execution plan. There is another one with a bitmap index scan as an execution plan. Now, in order to create that tuning set, you can use this ketchup_sts script file. I'm going to execute this, and this is going to create an SQL tuning set in which that select statement with its execution plans found inside the shared pool are going to be placed into. Then we're going to verify if those statements are inside that SQL tuning set called SPM_STS by running this script file. Now what do I see is that there are indeed two SQL statements. They are the same, but they both have a different execution plan inside that SQL tuning set called SPM_STS. And then we're going to use that tuning set to populate the plan baseline repository with those plans found in the SPM_STS SQL tuning set. And you can do so by running this script that does a load of plans coming from this specific SQL tuning set. Execute this. It has successfully completed. And now I'm going to check if those execution plans, the full table scan and the bitmap index scan for that statement, if they have been uploaded into the plan baseline. Now, what you upload yourself as plans are automatically baseline plans. So they will both be set to accepted value yes. So I'm going to run the script file. Now what do I see? That I have two execution plans being loaded into the SQL Plan baseline for that specific select statement. They have been manually loaded from an SQL tuning set, and what you manually load as execution plans are set by default being accepted plans. Then we're going to purge those plan baselines and drop that tuning set SPM_STS by running that specific script file. Now you also have the possibility to load plans from the cursor cache directly. So what we're going to do is we're going to execute a couple of statements so that their text and their execution plan are uploaded into the cursor cache, and then from there directly loaded into the SQL Plan Management base. So what we're going to do is we're going to run this script file. And if we're running that script file, I'm asking to perform an explain plan command for this select statement. It's the same select statement as before, except that the command is different. Optimizer mode is set to all rows, so it's going to be a full table scan. But now I'm going to run the query so that that statement and its full table scan execution plan are placed inside the cursor cache of the shared pool. Like this. Then we're going to put the optimizer mode to first rows, which will lead to the generation of a bitmap index scan execution plan. So I'm going to execute this. I'm going to show you the execution plan that will be created for that select statement right now by using that explain plan command. And you see that he comes up with a bitmap index scan. But to load it into the cursor cache, I have to actually execute that statement so that that text plus that bitmap index scan execution plan is uploaded into the cursor cache. So now I have the same statement twice in the cursor cache, but one using a full table scan, the other one using a bitmap index scan execution plan. Going to reset the optimizer mode back to all rows. Now, what we're going to do now is we want to load the execution plans of that statement found in the cursor cache. We would like to upload this into the SQL Plan Management base. For that, you can use the script loadcc baseline.sql. Executing this. And what you will see is it says, show me the distinct SQL ID for this select statement. That is that SQL ID. And then from that SQL ID, take all the execution plans out of the cursor cache and load them into the SQL Plan Management base. Then we're going to check if they were loaded. So I'm going to run this script file. Now what do I see is that I have two execution plans being uploaded into this SQL Plan Management base, and it was a manual load from cursor cache. And if you do a manual load, those plans are automatically being considered to be accepted plans. We're then going to empty the SQL Plan Management base by running this particular script file. And you will see that two plan baselines have been dropped, and that if I look up if there are baseline plans inside the SQL Plan Management base for this particular select statement, that they are no longer existing. Now that you know how to capture plans, look at how the optimizer selects which plan baselines to use. So first of all, you will create two baselines for a statement and show them being used. Then you will disable one of the baselines and see the second one being used. Finally, you will disable both baselines and show that now the optimizer falls back to the default behavior of a cost-based plan. Now, first of all, we're going to start by executing the same query twice with different plans. So what we're going to do is we're going to run this script file. This script file shows me when I do this select statement using that command spm_use with optimizer mode equal to all rows, that it comes up with a full table scan. Then I need to execute the query to have the query as well as its execution plan inside the cursor cache. So now this statement with its execution plan being a full table scan is now inside the cursor cache. Then what we do is we put the parameter optimizer mode to first rows, like this. And we're going to see what is now the execution plan that the optimizer would come up with for that same statement. So I'm going to rerun this script file again. And you see that he comes up with a bitmap index scan. To have that statement with the execution plan being a bitmap index scan in the shared pool, I will have to execute that query. So I'm going to launch this script again to have the statement and the bitmap index scan execution plan for that statement inside the cursor cache. Then at the end we put the optimizer mode back to all rows. Now I have twice the same statement inside my cursor cache. One having a full table scan execution plan, the other one having a bitmap index scan execution plan. But now I will have to load them into the SQL Plan Management base. So we're going to do this directly from the cursor cache. So I'm going to use baseline script file. I'm going to execute this to perform the loading. And you see that for that statement, I have now two execution plans that have been captured, that have been manually loaded. And like I've said already before, what you have loaded manually will always be set as an accepted plan. So a plan that can be used if it is generated by the optimizer. Then what we're going to do is we're going to see if the baseline and the execution plan is being used for that query. So what we're going to do is we're going to run this script, which will do the explain plan command, but it will show you a note at the end of the execution plan telling you if the system is using a baseline or not. From the execution plan, you will see that the first baseline is being used, the so-called full table scan. I'm going to copy this. I execute this. So here the explain plan happens. With the note, it's a full table scan, but it's a full table scan execution plan that is being picked up out of the history of that statement. And you can see which SQL plan baseline has been used. If I scroll back, this is the SQL plan baseline that has been used. You see that it ends with 8843. You see that this is the execution plan that he has used. Then what we're going to do is we're going to disable that execution plan baseline. So we're going to run this script file. And what does it do is, first of all, it's going to disable, so enable no, for that plan baseline 8843, which he was using before. And you will see when I'm looking at the SQL Plan Management base that this plan baseline that ends with 8843, that it has now been set to no as enable. So it's disabled. It means it's an execution plan that cannot be used if it has been generated by the optimizer. But then I'm going to say, look, explain plan for that statement. And I'm showing with a note the execution plan that was rendered, in fact. And what do I see is that he has used the other SQL plan baseline, the one that ends with BC0, which was that bitmap index scan. So he came up with a full table scan because optimizer mode is all rows. He saw that the full table scan execution plan is in the SQL Plan Management base, but it says enable no, so we cannot use it. So he's going to use the other baseline plan, the other one that is set to accepted yes. Then what we're going to do is we're going to also disable that second plan baseline. So we're going to run this script where we're going to, you see that here, also disable the SQL plan baseline that ends with BC0. So now both plans cannot be used. If then I would say explain plan for select, and I'm asking what execution plan did you use with the extra note information, what do you see is, yeah, he came up with a full table scan, but he didn't use one of the two SQL plan baseline because they have been deactivated, and the optimizer falls back to the default cost-based approach because there is no note at the end of the execution plan stating that the baseline has been used. We're now going to drop the baselines and check whether they have been purged. So I'm going to copy paste this script, going to execute this, and you see that those plan baselines for that select using the command SPM use are no longer in the SQL Plan Management base. One of the methods used to enable plan evolution or plan verification is automatic SQL tuning that is run as an automated task in a maintenance window. Automatic SQL tuning targets only the high-load SQL statements. For them, it automatically implements actions such as making a sex. One of the methods used to enable plan evolution is automatic SQL tuning that is run as an automated task in a maintenance window. Automatic SQL tuning targets only the high-load SQL statements. For them, it automatically implements actions such as making a successfully verified plan an accepted plan. Here, you manually trigger SQL tuning to find a better plan for a given SQL statement. First, you're going to determine the execution plan for the following statement. Now you're going to run a script file to run this statement, in fact, which has been decorated with some optimizer hints to ensure that you get a less than optimal plan first. So I'm going to run this script file, which is going to do an explain plan command for that select statement, forcing to perform 2 full table scans followed by a nested loop join. So I'm going to execute this. What do you see is, well, that this is the execution plan that has been generated, forcing the optimizer to go for full table scans followed by a nested loop. Then what you're going to do is we're then going to execute that statement so that the statement is placed in the cursor cache with that execution plan, and then from the cursor cache load that plan for that statement into the SQL Plan Management base. And you will see that that plan that you load, it's a manual load, is both enabled and accepted, but with the state not fixed. So I'm going to run this script file, which is here executing the statement. The statement is placed inside the cursor cache and that execution plan. Then we're going to obtain the SQL ID of that statement found in the cursor cache, and we're going to load the execution plan for that statement directly from the cursor cache into the SQL Plan Management base. And you see that I have here for my select statement this SQL plan being loaded. It is enabled, is accepted because a manual load always marks the execution plan to be accepted, but you see the state not fixed. Then what we're going to do is we're going to manually create and execute an SQL tuning task to tune your statement. For this, you can use the script tune evolve SQL file. So I'm going to run this task. So I'm going to say this is my SQL text. I'm going to create a tuning task and execute this tuning task. Once the tuning task has been completed, you can then run the report and see what recommendations have been made for your statement. Now there will be two recommendations being given by this tuning task, so-called SQL profile or a new index creation. By running this script, you can ask to show the report of that tuning task. So I'm going to copy paste this and I'm going to run this, where you can then look at what are the recommendations being made for this select statement. And it says, I have found here a recommendation, for instance, the creation of an SQL profile, which will lead to a potentially better execution plan with an estimated benefit of 98% of database time saved inside the database when executing that statement. Plus, there's also somewhere a recommendation where you can see the creation of an index. Now what we're going to do is we're going to accept the proposed SQL profile by the SQL Tuning Advisor. Now we can use this script file to accept the recommended SQL profile. Now I'm going to run this. So we're accepting this. Now what you see is that suddenly I have two execution plans for that select statement. The one that I have manually uploaded from the cursor cache, plus I have an execution plan that is being uploaded into the SQL Plan Management base by accepting the SQL profile from a manual run of the SQL Tuning Advisor. One is manual load, the other one is manual SQL tune. Both of them are enabled and accepted. Now we're going to determine which plan is used for your statement when you are executing it. So we're going to run this script file that does the explain plan command for my statements. In fact, I'm running this. I'm asking to display the execution plan plus a note, and you can see that an SQL profile has been used for this statement and that the execution plan is actually the SQL plan baseline that ends with 3816. And if I'm checking this 3816 execution plan is that execution plan that the SQL Tuning Advisor came up with. The only thing that we now need to do is to run this script to purge the environment for this practice.